So, we're experts on formulas. Some of us think so. That's more of a true statement than others. But we've learned the different types of compounds and stuff. But when I say formula, it refers more to something that looks like this. All right, that's a formula. What we're going to do today is look at two different categories of formulas, and it comes with some new vocab. We've got empirical formulas, and we've got molecular formulas. And based off some percent compositions, like we learned how to do earlier this week, we can come up with some different empirical and molecular formulas. Now, before I elaborate on that and explain what it means, we need to look at fractions for a second. C24H32. If I were to turn the subscripts of this into a fraction, it would look like this. Here's what I want you to do real quick in your notes. Write down 24 over 32. And then write all the different versions of that fraction that you can think of. And I'm talking about the ability to reduce it. In other words, another form of this fraction would be 12/16. Write the others. Don't let this scare you. We're not doing fractions, but I need you to understand an idea here. What are some of the other fractions that you came up with? Okay, 6/8. Somebody else give me one. All right, 3/4. Anybody write another one? I used the word reduction, so I didn't mean to mislead you, but what about 48/64? All right, that's actually another version of this fraction, but all of these mean the same thing because we're just reducing the numbers. Now, again, algebra is a prerequisite for my class, so if what I just did there makes no sense to you whatsoever, you need to come to tutoring because this is very simple math here. But here's the idea. An empirical formula is a formula where the comparison of numbers is in its simplest form. This would be an empirical version of the numbers. And what I mean by that is I could rewrite this formula to be C3H4. All right, notice what I did with the numbers. I just put them into their respective spots. But this was the simplest ratio of those subscripts. Again, by definition, an empirical formula is when the ratio of subscripts is as simple as it can go. A molecular formula is when it's anything else. These would be molecular versions of this formula. Meaning, if I went C12H16, I would say, well, that's a molecular formula because it's not in its simplest state when you compare the subscripts together. Does that make sense? So with that in mind, I can ask you some questions that I hope you'll think are the easier questions of today's topic. Can I erase this? And some of those questions go like this. Is that an empirical or a molecular formula? Don't answer. Give everybody a chance to think about it. Look back at what I just labeled a second ago. Look at the definitions. There's definitions of these things on your cheat sheet. Is this C2N4 empirical or molecular? What's the answer? It's molecular. All right. Now, most of y'all, I don't ever have to see you go through this step where you make it into a fraction. You don't have to do that. It's just what you think. But look, this is molecular because it can be simplified. I could turn this into 1/2, which would be CN2. All right, because we don't show ones, but 1, 2. This would be the empirical version of this molecular formula. Be careful. I want to know, is it empirical or molecular? Now, The fraction idea doesn't work as well here because there's 3 numbers, but you could even look at it like that. Could you turn all 3 of these numbers into a simpler number? Remember, you can't use a decimal or anything. Is this empirical or molecular? It's empirical. There's no number that I could simplify all of these into. Like, it looks like this could become a 3 and a 6 by dividing both of those in half, but I can't have a 2. You can't have a decimal number, so that doesn't work. This is actually empirical because I can't reduce all 3 numbers at the same time. Here's another fun question. First off, is water empirical or molecular? Empirical, all right, it's a 2/1 ratio. All right, I can't simplify that into smaller numbers. Write down a molecular version of this, though. Looking at H2O, I want you can write, there's a million right answers. Write down a molecular version of water. What are some of your answers? H4O2, that's good. What else? Is that everybody go with H4O2? All right, but to get that, if you multiply both of them by 2, it becomes 4/2, so 4/2. But we could have multiplied both of them by 11. All right, if you did that, it would become H22O11. But this would be a molecular version of this empirical formula. This one's molecular because it can be simplified. Divide both of them by 11. This one can't be simplified, therefore it's empirical. Do you see how I'm doing this? That's the concept part, not the process part. But you need to be able to recognize the difference. And again, just do a numerical comparison. With practice, you'll get good. Let's look at the skill now. With lots of space in your notes, write this down. What I have here is the percent composition of a compound. All right, these are the percentages that you've been finding this week. What we want to know is what is the compound? It's C something, H something, N something. I'm missing the subscripts, in other words. But based off these percentages, we've got a process we can use to find an empirical formula, a formula in its simplest form. If you go to your cheat sheet where it says empirical formulas, you'll see that there's a 3-step process by which we can turn these percentages into an empirical formula. Let's check out what that is. Step 1 says divide each element's given percentage. I gave you those percentages, I always will, by the periodic table mass of that element. So let's do each element. Carbon, again, it says divide the given percentage. That's 74.1 divided by, what's carbon's mass on the periodic table? Okay, 12.011. I'm going to get all my work set up before I run the arithmetic. Hydrogen, given percentage, was 8.6 divided by, what's hydrogen's mass on the PT? 1.008. And the same for nitrogen, 17.3 divided by 14.007. All right, so we haven't done anything crazy. Step 1, divide the percentage given by the mass on the periodic table. Let's get these values. 74.1 divided by 12.011. I get 6.17 here. 8.6 divided by 1.008, I get 8.53 here. 17.3 divided by 14.007, I get 1.24 here. So we've done step 1. Simple division. Let's see what step 2 says. Step 2, divide each answer that you got in step 1. All right, the red numbers are the answers that we got from step 1. It says divide each of those by the lowest number we got in step 1. What's the lowest red number that we got? 1.24. So listen to this step again. It says we're going to divide all of the red numbers, in my example up here, by the lowest red number. 1.24 is what we said that is. So we're going to divide all 3 of them by 1.24. And let's get some more answers. 6.17 divided by 1.24, all right, gives me 4.98. 8.53 divided by 1.24 gives me 6.88. And 1.24 divided by 1.24 is 1. Now here's the deal for our final step. These numbers that we got in black right here, they want to be the subscripts for our answer. Remember, what we're simply missing right now is that we know our formula is CHN, all right, carbon, hydrogen, nitrogen. We're just missing the subscripts. And these black numbers want to be the subscripts, but there's one little special rule that actually won't affect us on this question, but I want you to know it's there. We can round these numbers to those subscripts, and it's going to work beautifully here. But look on your cheat sheet. There's a little asterisk area, and here's what it says. If any of these black numbers end with a 0.4, 0.5, or 0.6, do any of these end with 0.4, 0.5, or 0.6? No. But it says if any of them do, then we have to multiply all of them by 2 and then assign the numbers. Now, that didn't happen here, so let's ignore that. Since none of them end in 0.4, 0.5, or 0.6, we can assign them as the subscripts. What will this round to? 5. What will this round to? 7. And the 1 stays a 1, so watch. 5, 7, 1. We're done. This is our empirical formula, C5H7N. It was a lot of fun going through that process, yes? Now, on the questions on your new online assignment, when it asks you for empirical formula, that's it. You would be done, and half of them will do that. However, the other half will ask you for a molecular formula. There's a given number over here that we haven't used yet because in empirical formulas, we don't need that number. But if we were in one of the other questions that said, what's the molecular formula? There's more steps. As you can see on your cheat sheet, I've got more steps for you. But let's continue the process. But understand, on some of the questions, we're done. We have found the simple ratio of numbers for this formula. Let's go down to molecular formula and pretend that that was the question. Molecular formulas. Step 1. It says calculate the empirical formula. Well, look, we did that. All right, just like percent composition to molar mass, you can't find a molecular formula unless you've already done this part. All right, So we found the empirical formula. Let's move to the next step. Find the molar mass of the empirical formula. Uh-oh, molar mass. That's earlier week stuff. Let's do that here. We need to find the molar mass of him. So if you don't remember how to do that, flip to the other side of your cheat sheet. The steps are there for molar mass. It says step 1, make a list. C, H, N. It says count how many there are. 571. 571. I'm just counting my empirical formula. Multiply by the periodic table. All right, that's 12.011, 1.008, 14.007. We already found those values earlier in this problem. We'll get some numbers here. All right, this is going to be 60.055, it looks like. This will be 7.056. This 14.007. If I write down a number that confuses you, shout at me. I don't want to move beyond you, but this part's review. What do we do with those three numbers that we just got? You add them up. Again, I'm reading straight off the steps from the molar mass process on the other side of your cheat sheet. I don't know this number though. 60.055 plus 4.056 plus 14.007. I get a molar mass of 81.12. All right, so here's a molar mass that I calculated from the empirical formula that we found earlier. Let's go back to our cheat sheet that's telling us what to do. Step 3, listen closely. Divide the given molar mass. See that molar mass right there that was given to us that we haven't done a single thing with yet? It says divide the given molar mass by the mass of the empirical formula. All right, well, let's do that. The given molar mass was 160. It wants us to divide that by 81.12. And I get an answer of 2. Verify on your calculator that you get a basic answer of 2 for that. And then we can move to finally the last step of the process. The last step says multiply every subscript in the empirical formula. Multiply every subscript by that number. And you're done. When I multiply these subscripts by 2, it becomes C10, H14. I know how to write numbers. N2. And look what we have formed, guys. It took a long time, and I told you would like this less than the other stuff, but we have an empirical formula, and we have a molecular formula. Based off the definitions I already gave you, it should be obvious why we would call him molecular. He could be simplified. He can't be simplified. Empirical. Let's do another one from scratch so that we can think this is easy. Here's some new givens. Work with me. We're going to make a compound made of magnesium and nitrogen this time. The compound is 72.2% magnesium and it's 27.8% nitrogen. I have a little bit of extra information here just in case I'm mean and ask for a molecular formula. Remember, if I ask for an empirical formula, we don't need that molar mass. All right, let's work together. Back to the cheat sheet. What is the empirical formula is the question. Step 1 says divide the given percentages by the PT masses of the elements. Magnesium's given percentage is 72.2. I want to divide that by magnesium's mass of 24.305. Nitrogen's percentage is 27.8. I want to divide that by his PT mass of 14.007. And we've got some values we can get here. 72.2 divided by 24.305, I get 2.97. For nitrogen, 27.8 divided by 14.007, I get 1.98. Step 2 states, divide by the lowest number we just got. What's the lowest number we just got? 1.98. So we're going to divide both of them by 1.98. I'll get 1 for nitrogen. Let's find out what magnesium is. I get 1.5 for magnesium. Now remember, those numbers, these step 2 answers that we get, are supposed to be the subscripts that we're looking for. The little number there and the little number there. But there was a side note that I said. If any, listen closely, if any of these numbers end in 0.4, 0.5, or 0.6, then we multiply all of them by 2. Is that rule going to come into effect here? Yes. Do you see the 0.5? 1.5. That's no good. So just to see the plan in action, instead of us rounding and assigning them here, it says we need to multiply all of them by 2. What's 1.5 times 2? It's 3. There is our magnesium subscript. What's 1 times 2? There is our nitrogen subscript. Ta-da! And we have found an empirical formula. Hopefully that felt like it went a little bit smoother this time than last time. All right, so make a little note. That's our empirical. All right. And if we were on the good half of that assignment, we would be done. But let's say that we weren't. Let's say we're on the bad half. And instead it wanted to know what's the molecular formula. Let's continue the process. Step 1 of molecular is find empirical. Did it. We're good. Step 2 says to add up him. So let's add up the molar mass of the empirical. My empirical formula is made up of magnesium and nitrogen. It appears there are 3 magnesiums and 2 nitrogens. I need to multiply that times the PT mass. We already found that mass. For magnesium, it was 24.305. Nitrogen, 14.007. We do our math. Magnesium looks like it's going to be 72.915. Somebody might want to verify that for me. I'm taking liberations with my brain here. Nitrogen will be 28.014. Add them together for the molar mass. We'll get 91905. 100.919. Remember what we have found here. We found the mass of the empirical formula. Our cheat sheet says we need to divide the given number, 404, the number we haven't touched yet. We're going to divide him by 100.919. Is it? Oh, you're right. You're right. Dun, dun, dun. You're going to get the same answer over here on this end, but thank you for catching that. What do you get? 4. I get 4 as my number there. What are we supposed to do with that 4 as our final step? Multiply our subscripts of our empirical by that number. 3 times 4 is going to be 12 magnesiums. 2 times 4 is going to be 8 nitrogens. And there's your molecular. Isn't this awesome? Welcome to the second semester. Yay. Last problem. Oops. This compound is going to have beryllium. We're going to have 7.3% of it. It's also going to have phosphorus. We'll have 49.9% of that. And chlorine, we'll have 42.8% of that. I'm going to give you some bonus info here. 744 grams per mole is the mass of the molecular formula that I want you to find. The question is, what is the molecular formula? Take your time, use your cheat sheet, look at previous examples, don't skip any steps. Call me over if I can help you. You might want to pause this video while you work. Taking a look at my work, I divided the percentages by the PT masses and got these 3 top black numbers. The smallest one was 0.81, so I divided all of them by 0.81 and got these step 2 answers. One of my step 2 answers ended in 0.4 though. Remember, if any of them end in 0.4, 0.5, or 0.6, we have to do this extra step of multiplying all of them by 2. And this gave me an empirical formula of Be2P4Cl3. If the problem had been asking me for an empirical formula, which I will, we'd be done. We pretended that we were being asked for molecular, though, in which case we needed to find the molar mass of the empirical, which was 248, divide the given molar mass of 744 by the calculated empirical mass, and it gave me an answer of 3. Therefore, my final answer of the problem would be multiplying my empirical values by 3, which would give me 6 berylliums, 12 phosphoruses, and 9 chlorines. Questions? I got